Ayun. So, magandang araw sa inyong lahat. So, nag-upload na ako ng part 2, no? Yung kinematics and one dimension dun sa SPC Leons natin. So, nagbigay din ako ng libro na ginagamit ko para ma-check nyo, no? So, i-discuss ko ngayon is nandito na sa kinematics. So, yung kinematics natin is nahati sa dalawa. C1 dimension and C2 dimension. Okay? So, you can download the presentation dito sa ating CSPC Lions para maging guide nyo rin. Okay? So, this is the explanation of that presentation. Okay, so balik na ako dito. No? So, yun na nga, i-discuss ko ngayon is the kinematics in one dimension. Okay? So, let's start. So, yung kinematics natin in one dimension is nahati sa pito. Pito na topics. Okay? Nandiyan si displacement, suspended velocity, si acceleration, si equation of kinematics for constant acceleration, as application for the equation in kinematics, saka yung freely falling bodies. Tapos yung graphical analysis of velocity and acceleration. Okay? So, let's start na, magsimula tayo kay displacement. Okay? So, meron dalawang aspeto ng tinatawag na motion. In purely descriptive sense, there is the movement itself. Okay? It is rapid or it is slow. Then there is the issue of what caused the motion or what changing it, which requires the force be considered. So kinematics deals with the concept that are need to describe motion without any reference to force. So to present this topic, let's discuss this concept as applying motion in one dimension. And yung susunod nating chapter naman is yung two-dimensional. So dynamics deals with the effect that forces have on motion, a topic that is considered in chapter number 4 or yung tinatawag, yung papasadahan natin na first and Newton's law of motion. Okay? Together, kinematics and dynamics from branch of physics known as mechanics. So we turn now the first of kinematics concept to be discussed. Okay? So the definition of displacement is the displacement is a vector that points from object initial position to its final position and has magnitude that equals the shortest distance between the two positions. So kung makikita nyo dito sa image, no, dito sa picture na pinapakita, nag-travel yung isang object, no? Nag-travel yung isang object. Pero kung mapapansin nyo, yung distance niya sa dulo ng track is 70 and yung displacement niya is 14. Okay? Kasi ang tinitingnan ng displacement is yung pinakamalapit doon sa two positions, yung end and yung start. Okay? So dito, ang unit na gagamitin natin para sa ating displacement is meters. Ayun. So, pasok tayo ngayon dito sa speed and velocity. So, hindi na ako masyadong magtatagal doon sa displacement, no? Kasi napakadali lang 'yun. Okay? Kukunin mo lang yung shortest distance of ending and starting point. Okay? So, punta tayo dito sa velocity. So, one of the most obvious features of an object in motion is how fast it is moving. So, titingnan natin gaano daw kabilis yung isang object na 'yun. If a car travel 200 meters in 10 seconds, we say its average speed is 20 meters per second. Okay? The average speed being the distance traveled divided by the time required to cover the distance. So, dito napakadali lang na ang ating formula, no? Ang average speed natin is equal to distance over elapsed time. So, for example, no? How far does a jogger run in 1.5 hours or 5,400 seconds if his average speed is 2.22 meters per second? Okay? So, open muna ako nung Blackboard natin. So, dito, hindi na tayo mahihirapan, no? Meron tayong formula. No, meron tayong formulang ginagamit. So, displacement. So, our displacement So, ano daw yung formula ng ating average speed? Average speed is equal to distance over elapsed time. No? So, sa ating example, meron siyang ibinigay na time. Okay? May binigay siya na time. Yung time na binigay niya is 1.5 hours or 5,400 seconds. Ayan. So, meron din siyang ibinigay na average speed. So, abbreviate ko na lang. Average speed. Ang average speed na ngayon ay ibinigay na 2.2 meters per second. Okay? So, ang tanong is how far? So, ang kukunin natin dito is yung distance. Ayan. No? So, while meron na tayong formula, pwede nating ipasok dun. No? Pwede nating ipasok yung mga given natin. Kunwari, average speed is 2.2 meters per second. Or, para mas malinaw, gagawin kong ganito. Is equal to distance over time. So, ano yung distance natin? Yung hinahanap pala, no? Distance over time. Yung time natin is 5,400 seconds. So, makakancel si seconds, no? Makakancel. So, using our calculator, mapapalabas natin yung answer. No? I-multiply na lang natin. 2.2 times 5,400. Teka. Okay. So, yung distance natin, lumabas ngayon yung distance is 11,880 meters or approximately 12,000 meters. Okay? So, our answer. Sir, paano kung nakalimutan ko yung formula? So, tuturuan ko kayo ng isang diniscuss natin to ni last chapter dito. So, paano kung nakalimutan ko, sir, yung formula? Okay? Ito yung sinatawag nung instructor ko noon na Bobo method. Okay? So, dito, kunwari, meron kang given, so meron kang given, no? Ang given mo, 5,400 second, and may ibinigay din na average speed na 2.2 meters per second. Tapos nabasa mo sa problem, how far? So, ibig sabihin, distance yung hinihingi. Okay? So, dito, pag nag-unit analysis ka, katulad ng sinabi ko nung nakaraan, no, pag nag-unit analysis ka and natandaan mo, wala naman siyang constant, so pwede mong gamitin yung unit analysis kung nakalimutan mo yung formula. Kung wari, meter per second, ibig sabihin, meter per second, syempre magiging meter per second din yan. Dahil minigay siyang 2.2, lagyan natin ng 2.2, no? Tapos may binigay siyang second. May binigay siyang second. Ang binigay niyang second is 5,400 second. Tapos makikita mo, no? Makakancel to. Kasi may binigay siya. So, ang matitira, yung meters. So, pwede mo na ngayong mahanap yung nandito. Okay? So, i-multiply mo ito doon. So, ganun din ang lalabas. No? Ang lalabas dyan is yung katulad kanina. Ito. Okay? So, ganyan lang siya kadali. Okay, balik tayo sa topic natin. So, okay na to? So, punta naman tayo dito sa tinatawag na average velocity. So, ano tong average velocity na to? So, to define the velocity of an object, we will use two concepts that we have already encountered. Displacement and time. So, the building of new concept from more basic one is a common theme in physics. In fact, the great strength of physics is a science is that it build a coherent understanding of nature through the developing of interrelated concept. So, ang definition ng is average speed is the displacement over the elapsed time. So, pwede nating sabihin na from x final minus the x initial all over time, final time over time initial. So, magiging change in x and change in t. So, dito, ang gagamitin nating unit dahil sa libro na to, meters per second. Okay? So, tingnan natin kung may example. Ayan. So, meron tayong example dito. So, example number 2, Andy Green in the car thrust SSC set a world record of 341.1 meters per second or 763 miles per hour in 1997. The car was powered by two jet engines. And it has the first one officially to exceed the speed of sound. To establish such a record, the driver makes two runs through the course, one in each direction, to nullify wind effects. Okay? So, meron pala siyang ibinigay na figure no, na hindi ko nalagay dito. So, wait lang. Lagay ko muna yung figure, no? Lagay natin yung figure na nakalimutan ni Sir. Saan yun? Dito. So, yan. So, ito yung figure. No? Figure 2.3. Show the car first traveled from left to right and covers a distance of 1,609 meters or 1 mile in a time of 4.74 seconds. So, figure 2B, itong nandito, show that in the reverse direction, the car covers the same distance in 4.695 seconds. From this data, determine the average velocity for each run. Okay? So, dito raw, hanapin natin yung average velocity. Okay? So, i-redraw ko muna yung drawing niya, no? So, unang lakad or unang takbo nung jet engine niya, syempre, mag-i-start siya, may initial siya na T0, no? May start siya na T0 equals to 0 second, no? Tapos ngayon, tumakbo siya. Ito yung distance, no? Ang change of distance na binigay sa kanya, oops, ba yan? Dapat talaga straight line na ginagamit ko eh. Mapangit tuloy yung drawing ko. Okay? So, kunwari, ito yung binigay na distance. Ayan. So, kung meron tayong change in distance dito, no? Yung change in distance dito is, balikan natin yung problem para sigurado. Yung change in distance dito is, ito, left to right covers a distance of 1,609 meters. Okay? So, yan. So, ibig sabihin, 1,609 meters to. Ayun. So, natapos niya, kunwari nandito yung object, ganito na lang. Tumakbo siya, no? Papunta dun. So, ito yung final time niya. Nung nakaabot siya dito sa 1,609, yung time niya daw na na-cover is 4.740 second. Ayan. Ito yung papunta. Tapos, bumalik siya ngayon. Okay? Ito na yung pagbalik niya. Ayan. So, dito naman siya mag-start. No? So, ito naman yung T0 or initial time na 0. Tapos, dito naman siya nag-stop. No, tapos, ang kinovered na time daw dito is 4.695 seconds yan. Ha? Okay? So yung tinakbo niya dito, papunta doon, is nagbigay ng positive. Okay? Doon sa change of distance natin. Okay. So from here, syempre parehas pa rin yung distance. Kaso bumalik. So dahil sa pagbalik niya, naging negative na yung distance niya. Okay? So yung change of time, change of distance naman dito is magiging negative 1609 meters. Kasi bumalik. Okay? So from left to right, positive. Right to left, negative. Okay. So parang ganyan siya. Yung figure. Ngayon, isosolve na natin siya. So dito muna tayo sa run 1. Run number 1. So yung average velocity natin dito, no? Ito, average velocity is equal to change in distance or x over the change in time. So dito, yung change of distance natin is positive 1609 meters over 4.74 second. Okay? Velocity pa lang pala to, hindi pa average, no? So dito may lalabas dito. Gamitin natin yung calculator. 1609 divided by 4.74. So lumabas dito is 33. 339.5 magiging meters per second. So run number 2, okay? So ganun pa rin ang formula ang gagamitin natin. Change of x over t. So dito naman, negative na siya kasi bumalik. Tapos nag-iba yung time niya. Siguro nag-iba yung time dahil dun sa hangin. So, magiging 1609 divided by 4.695. Magiging 342.7 meters per second. So, yan. So, ito na yung average speed, no? Ito na pala yung average speed. Ito na yung average speed nung run 1 and nung run 2. So, ganun lang siya kadali. Okay? So, pasok tayo dito sa tinatawag na instantaneous velocity. So, the instantaneous velocity of the car indicated how fast the car moves in the direction of the motion at each instant of time. Oh. So, the magnitude of the instantaneous velocity is called the instantaneous speed. It is the number with units. So, ito yung makikita natin doon sa ating mga speedometer. Okay? Ibig sabihin, Yung speedometer natin, ang nababasa niya is instantaneous velocity. So, papaanong instantaneous velocity? Ito yung velocity na meron siyang exact time. So, paano natin explain yun? Kunwari, merong isang bus na nasa expressway, no? So, ang speed niya is 60 kilometer per hour. So, yun yung instantaneous velocity niya doon sa time na yun. Tapos, biglang nag-traffic, no? Dahil mabilis yung expressway, tapos biglang nag-traffic doon sa toll gate, bumaba ngayon ng 20 kilometer per hour. So, yung 60 kilometer per hour is yung instantaneous velocity niya nung wala pa yung traffic. So, nung magka-traffic, yung instantaneous velocity niya is nasa 20 kilometer per hour na lang. So, yung instantaneous velocity is kung ano lang yung nasa given time na yon. Okay? So, meron tayo ditong formula ng instantaneous velocity na puti lang. So, meron tayong formula ng instantaneous velocity na limit ng change of time approaches to zero. So, change in distance over change of time. Yan. So, the notation of this formula means that the ratio of change of distance over the change of time is defined by the limiting process, which is smaller and smaller values of time are used to. So, small that approach to zero. So, as a smaller value of t are used, delta x also smaller. However, the ratio of the um, change in distance over the change of time does not become zero, but rather approaches the values of instantaneous velocity. Okay? So, yung tinatawag na instantaneous velocity. So, pasok tayo ngayon dito sa tinatawag na acceleration. Okay? So, medyo, ano na to, advanced na. In a wide range of motion, the velocity changes from moment to moment. To describe the manner in which it changes, the concept of acceleration is needed. Okay? So, kapag pabago-bago nga ngayon sa velocity, andito na ngayon yung tinatawag na acceleration. Okay? So, ito yung formula ng ating acceleration. So, change in velocity over the elapsed time, or pwede nating masabi na acceleration is equal to the final velocity minus the initial velocity over the final time minus the initial time. Or sabihin na lang natin na delta V over delta T. So, ang unit natin dito is meter per second square. Okay? So, dito meron din tayong tinatawag na instantaneous acceleration, no? So, ang instantaneous acceleration naman, parang yung instantaneous velocity. Limit din siya na yung time mo is approaches zero, pero ngayon, velocity na to over the change of time. Kasi nga, ito yung formula ng acceleration, velocity over time. Okay? Ngayon, punta tayo sa example natin. So, suppose the plane in figure 2.4 or ito, plane na to, start from rest or initial velocity niya is 0 when initial time is 0 din. The plane accelerate down the runway and at t is equal to 29 seconds. Attain a velocity of 2.6 to 260 kilometer per hour, where the plus sign indicates the velocity points to the right. Determine the average acceleration of the plane. Okay? So dito, hanapin daw natin yung average acceleration. So, paano natin kukunin yon? So, gamitin natin yung formula. No? Acceleration is equal to b for velocity. Final, tapos initial velocity over time minus initial time. Okay? So, isa-isayin natin. Gawa ako ng figure. Ayan. Kunwari, ito yung runway ng eroplano. So, ang mangyayari, ng eroplano daw, paano ba drawing ng eroplano? Ganito ba eroplano? Yan. Pasensya nyo na drawing ko ha. Yan, kunwari eroplano yan, papunta dito. So, kunwari yung eroplano, ganyan yung itsura. So, sabi niya, yung initial daw niya is 0, hindi pa umaandar yung eroplano. Okay? Siyempre yung time nun, initial din, t0. So, the plane accelerate nag-accelerate siya sa loob ng oras na 29 seconds. And yung velocity niya is naging 260 km per hour. Okay? So, gamitin natin yung formula. So, ang mangyayari dito, hanapin natin yung final velocity. Yung V natin is 260 positive kilometer per hour. No? Minus the initial. Yung initial niya daw is 0. Okay? Over final time. Ang final time natin is, di ba nag-accelerate siya sa loob ng 29 second? Tama. So, 29 second na naman. 29 second. Minus the t initial na 0. Tama. 0 yun. Kasi naka-rest lang siya eh. Okay? So, let's solve this. So, calculator na lang, no? Magiging 260 over 260 over 29. Magiging approximately 9. Okay? So, approximate na lang natin 9. 9 kilometer per hour over second. No? So, para ma-simplify yan, kailangan kilometer or meter per second dapat ang lalabas. Okay? So, ang maganda siguro dito, Balikan natin yung problem. Ito, balikan natin 'to. Siguro maganda i-convert muna natin 'to, yung 260, okay? So, magiging 260, iko-convert natin yung 260 kilometer per hour, ko-convert natin siya ngayon ng meter per second. Okay? So, paano natin yan mako-convert? So, 260 kilometer, dito na lang. 260 kilometer para unahin natin yung kilometer, no? So, in 1 kilometer, how many meters? 1,000 meters. Hindi to equal. Multiply ito. Tapos, i-multiply din natin yung R. So, in 1 hour, ilang second? Double check natin ha. In 1 minute, there's 60 second. Tapos, 60 minutes, 360. 3,600 second. So, check natin. Check natin siya, no? Yung kilometer, makakancel. Okay? Yung R, makakancel. Then, matitira meters per second. Okay? So, makukuha na natin ngayon yung convert nito. So, 260 times 1,000 times 1 over 3,600. So, yun, 72.2. Tama, 72.2. So, magiging 72.2 meters per second na to. So, ang lalabas dito, no? So, ito bababa to, magiging, so, magiging meter, bababa yung second, magiging square second. Second square. So, 72.2 divided by 29. So, yung acceleration natin is magiging 2.4. Acceleration natin is magiging 2.4. 8 meters per second. Ito yung sagot natin doon sa problem. Dito. Okay. So, okay na tayo acceleration. So, meron pa tayong example number 4 para sa acceleration and decreasing velocity. Okay? Sabi niya, a drag racer crosses the finish line. No? Wait lang. So, a drag racer crosses a finish line and the driver deploys a parachute and applies the brake to slow down. So, makikita natin siya dito sa figure na ito, no? Yung figure na to. Yan, yung figure na yan. So, the driver begins slowing down from when the initial time is 9.9 seconds. And the car velocity is positive 28 meters per second. So, nung yung time niya is maging 12 second na lang, yung velocity niya is nag-reduce ng 13 meters per second. What is the average acceleration of the dragster? So, ang senaryo na to, siguro nagka-problema ngayon yung race car niya. So, para mas mapabilis yung preno or mas mapabilis yung pagbagal ng kanyang sasakyan is kailangan niyang mag-open ng isang parachute sa likod. Okay? So dito pinapa-compute sa atin yung average acceleration. Yan. So punta tayo ngayon dito sa blackboard. Yan ang tunay na blackboard. Kulay itim eh. Okay? So let's start. So alam natin ang formula ng acceleration is equal to V final minus the V initial over the T final minus the T initial. So, papasok lang natin lahat ng given dito, no? So, ang ibinigay niya, check natin kung naka-meters per second. Okay, naka-meters per second naman nung chinek natin, no? Yan, naka-meters per second naman. Hindi na tayo magko-convert. Okay? So, yung final velocity niya is 13. No? 13 meters per second. So, yung final initial niya is 28 nung hindi pa siya nagbubukas ng parachute. So, nung hindi pa siya nagbubukas ng parachute, hindi pa siya cute nun. De joke lang. So, over time, yung time natin is, yung final time is 12 seconds. Minus 9 seconds yung initial time niya. Okay? So, ang lalabas dito is magiging meters per second square. Square second. So, using your calculator na lang, no? Magiging 13 minus 28 over 12 minus 9. Ang lalabas ngayon is negative 5. So, ngayon, anong ibig sabihin ng negative dito sa lumabas na value? So, ganito lang siya. Kapag positive ang lumabas, ito yung tinatawag na acceleration. Pag negative ang lumabas, ito yung tinatawag nating, ano yung tawag doon? Pag negative. Deceleration. Tama? Oo, deceleration. Okay. So, ito na yung magiging acceleration niya, no? No, bumukas na yung parachute. Hindi na siya acceleration pala. Deceleration niya. Kasi nag-deaccelerate siya eh. So, ito na yung deaccelerating niya. 5 meters per second. So, yun. So, ngayon, punta tayo dito sa topic number 4. The equation of kinematics for constant acceleration. So, it is now possible to describe the motion of an object traveling with a constant acceleration along the straight line. To do so, we will use a set of equations known as the equation of kinematics for constant acceleration. This equation entail a new concept because they will be obtained by combining the familiar ideas of displacement, velocity, and acceleration. However, they will provide a very convenient way to determine the certain aspect of motion shot, such as the final position and velocity of a moving object. So, ito yung ginagamit na formula ng mga agila. Matalino kasi yung mga agila, no? So, kapag yung agila daw lumilipad, sabang tinitingnan nila yung prey nila, kunwari meron silang nakikitang rabbit sa sa ibaba na parte, no? So, tinitingnan na nila, tapos kino-compute nila yung equation of kinematics for constant acceleration para pag lumusob sila, saktong-sakto yung dakmaan ng mga agila. So, bubuti pa yung mga agila, ang gagaling mag-compute. Okay? So, in this case, the equation of kinematics, it will be convenient to assume that the object is located at origin. Tayo sa blackboard, no? So sabi dito, para convenient daw, i-assume natin na yung object is located sa origin. Okay? So ibig sabihin, yung origin natin, yung initial point natin is equal to 0. When time initial is 0. So nakarest siya. So with this assumption na displacement, so yung displacement natin, yung change of distance, yan, is equal to final x and initial x. Becomes, so sa ganito daw, di ba? So sa ganitong senaryo kasi, dahil 0, yung ano natin, yung XO, no? Magiging 0 to. So yung change in x natin is magiging the final x na lang. Okay? So furthermore, in the equation that follows, it is customary with we dispense with the use of boldface symbol overdrawn with a small arrow for the displacement. So velocity and acceleration vector. We will, however, continue to convey the direction of this vector with plus or minus sign. So consider an object that has initial velocity of v at time 0 second and moves from the time t with a constant acceleration na a. For a complete description of the motion, it is also necessary to know the final velocity and displacement at time t. So the final velocity can be obtained by this equation. So A natin is equal to a, acceleration, no? Magiging b minus b initial, b final over minus b initial over t. Okay? Or pwede nating sabihin na v is equal, b final is equal to b initial plus at. Okay? And paki-take note ang formulang to. Kasi ang formulang to is kadalasang lumalabas sa mga board exam. So ang formulang to ay tinatawag na constant acceleration. So pakitandaan palagi yung formulang yan. Okay. So the displacement x at time t can be obtained from the equation na ganito. B, oops, bakit pula na naman yan? B or velocity is equal to x final minus x initial over final time minus time initial. Or simply magiging x over t to. Magiging x na naman, x over t. Or pwede nating sabihin na x equals to velocity multiplied by time. Okay? Okay. So because the acceleration is constant, the velocity increases at a constant rate. Thus the average velocity is midway between the initial and the final velocity. Okay? So dahil doon makakapag-formulate tayo ng B, velocity is equal. Sabi niya, nasa kalahati, 1/2 ng B initial plus the final velocity. So ito, pakitandaan 'tong formulang 'to 'no, lahat ng hina-highlight ko na formula pakilista. Kasi kadalasan talaga lumalabas sa mga board exam 'yan, okey? Ito yung tinatawag na constant velocity. Hindi, mali, mali, mali. Hindi siya constant velocity. Ito yung tinatawag na constant acceleration, okey? Mali, sorry, sorry, nahihilo na rin ako. 'Di pala 'to constant acceleration. Ito pala yung tinatawag na average velocity. Sorry guys, nagkakamali rin. Average velocity. Okay? So, galing dito sa equation na to, pwede natin siyang apply sa mga acceleration na merong constant and um, yung mga hindi pwedeng gamitin kapag merong change of acceleration. So, tandaan nyo lang to na formulang to is hindi to pwedeng gamitin sa mga merong nagche-change na acceleration, no? So, magagamit mo lang 'to kapag yung acceleration is constant, okey. So, meron pang isang formula, yung formula na x equals to bt or 1/2, 'yan. So, dito makukuha natin yung displacement kapag nilagyan na natin siya ng time, okey? So, ayun. So, meron tayo ditong example 'no. So, example number 5, the speedboat in the figure below has a constant acceleration of 2.0 meter per square second square. If the initial velocity of the boat is 6 meter per second, find the boat's displacement after 8.0 second. Yan. So meron daw siyang constant acceleration, no? Meron siyang constant acceleration na 2.0 meters per second. So if the initial velocity of the boat is 6.0 meter per second, find the boat's displacement after 8.0. So ngayon hahanapin natin yung displacement, no? So dito magagamit natin yung formula na x is equal to 1/2 the initial velocity plus the final velocity multiplied by time. Pero, kaso, itong final velocity natin is hindi natin alam. Okay? Tama. Meron siyang binigay na ano eh. Meron siyang binigay na time. Di ako nagkakamali, may binigay siyang time. 8 seconds. Meron siyang binigay na initial velocity. No? Initial velocity of 6 meters per second. Makukuha sana natin yung x. Kaso hindi natin alam tong b. So, paano natin siya makukuha? Okay? So, pwede nating makuha yan gamit yung formula na B is equal to initial velocity plus acceleration multiplied by time. No? Binigay ko ba yan? Alam ko binigay ko yun eh. Ayan. Ito. Constant acceleration. No? Merong ibinigay na acceleration, merong binigay na time. So, pwede nating ipasok tong B na to dito. Okay? So, paano yun? So, magiging x is equal to 1/2 BO plus, palitan ko to. Wait lang. Gawin natin tong stapler. BO plus the quantity BO plus AT. Ayun. Ayan na guys, no? So ngayon, pwede na natin siyang ipasok. Okay? So magiging 1/2. Ano yung velocity natin? Initial. Balikan natin yung problem. 6 meters per second. Magiging 6 meters per second plus 6 meters per second plus yung acceleration natin. Oy, nakalimutan natin yung ano, yung time dito, no? May time yan eh. Usin nga natin. Yan. Stapler to. Wait lang. So dito, no? Yung acceleration natin, ibinigay din. Ano yung acceleration? 2. 2 meters per second square. At wala stapler din to. Ito magiging bracket. Yan. Bracket to. Multiply po pala na ng time dito, no? Multiply po muna ng time. 8 second. Tapos, bracket. Time. Wag na natin yung time. 8 seconds na to. So, 8 seconds. So, makukuha natin yung x. So, using calculator na lang, no? So, magiging 1/2. 1/2. Papasok ngayon si 6. Plus, bracket. 6 ulit. Plus, 2. Pasok natin to. Times 8. 1, 2, 3. 1, 2, 3. Kulang ng isa. Tama. Tama. Multiply by 8. Okay. So, lalabas. Yung distance natin is 102 meters na yung final answer. So, ayan. So, sa mga itong problem, tandaan lang natin yung mga formula natin, no? So, ayun. Yun yung answer dito sa example number 5. So, screenshot nyo to, no? Ito yung mga formula. Ayan. Equation of the constant acceleration. So, next tayo. So, dito na tayo sa topic number 5, no? So, application of kinematics. So, the equation of kinematics can be applied to any moving object such as the acceleration as long as the acceleration of the object is constant. However, remember that each equation contains four variables. Therefore, numerical values for three of the four must be available if an equation is to be used to calculate the value of the remaining variable. To avoid errors when using this equation, it helps to follow a few sensible guidelines. To be alert for a few situation that can be arise during your calculation. So ano yun? Guidelines na yun. So, problem solving insight, decide at start which direction are to be called positive and negative relative to a conveniently chosen coordinate origin. So, katulad kanina, kunwari yung papuntang right is positive, papuntang left naman is negative. So, this decision is arbitrary. So, nakadepende sa inyo. But important because displacement, velocity, and acceleration are vectors. So, ibig sabihin, meron siya ng direction. And their direction must always be taken into account. And in the examples that follows the position, the positive and negative direction will be shown in the drawings that accompany the problems. It does not matter which direction is chosen to be positive. However, once the choices is made, it should not be changed during the course of calculation. Okay? So pag nag-assume na kayo na yung papuntang right is positive and yung papuntang left naman is negative, panindigan nyo na hanggang sa dulo ng calculation nyo. Okay? So, meron pang isa. As you reason through a problem before attempting to solve it, be sure to interpret the terms decelerating or deceleration correctly. Should they occur in the problem statement? So, this term are source of frequent confusion and conceptual. So, katulad yung problem natin kanina. So, yun. Kailangan nating i-understand kung ano ba yung ibig sabihin ng decelerating saka deceleration. So, decelerating, kapag nagde-decelerate siya, no? So, kunwari, yung sasakyan is decelerating at 5 meters per second squared. Magkaiba yun sa deceleration, no? Yung deceleration kasi is yung constant na yun. Okay? Constant na yung pag-decelerate. Parang acceleration din yan. So, magkaiba yung accelerating sa acceleration din. Okay? So, yun. So, para mas maintindihan natin, yun, kailangan natin mag-solve ng problems. Okay? So, meron tayo ditong example. A motorcycle ride consists of two segments, as shown in the figure 2.12a. So, ito siya. During segment 1, the motorcycle start from the rest. So, ibig sabihin, nagsimula din siya sa rest. has an acceleration of 2.6 meters per second positive and a displacement of positive 120 meters. Immediately after sa segment 1, the motorcycle enters segment 2 and begins slowing down with acceleration of 1.5 meters per second until the velocity is positive 12 meters per second. What is the displacement of a motorcycle during the segment 2? Okay, so paano natin ito i-approach? Paano natin siya i-approach? So, dun daw sa figure 2B, no, yung segment 2, two variables to final velocity and acceleration are known. So, alam natin yung velocity, tapos yung acceleration, 2. And for convenience, we choose the equation na gamitin natin dito yung equation na B. So, lagyan ko na ng 2, no? B squared is equal to BO 2 square plus 2 AX. Ayan. So, gamitin natin yung ano na yan, formula na yan. And pwede nating ilabas ngayon yung x2. So, kapag nilabas natin yung x2 or yung displacement natin, may kakalabasan ng formula na b2 square minus the initial velocity over 2a. So, ayan yung kinalabasan niya. Wait lang guys. Pero dito sa formulang to, meron tayong naging problema. Ang problema natin dito, hindi natin alam yung initial velocity. Okay? Hindi niya ibinigay. So ngayon, papasok dito yung formula na initial velocity square equals to velocity number 1. Saan yun manggagaling yung velocity number 1 na yun? Okay? So yung velocity number 1, sabi niya kasi, during the first segment, the motor's cycle start from rest. Tapos nag-acceleration ng 2.6 meter per second. Tapos nag-displace siya ng 120 meters immediately from after segment 1, the motorcycle enters the segment 2. Begin slowing down in an acceleration of negative 1.5 meters per second until nakakuha siya ng velocity na 12 meters per second. 1.5 meters per second square pala to. Okay? So, ibig sabihin, yung velocity kasi niya, velocity number 2 niya is equal dun sa velocity number 1 niya na nasa first segment. No? Yung initial. So, yun. Pwede nating sabihin na yung B initial na 2 is equal to yung final velocity 1 niya dun sa segment 1. No? Ganun lang. Okay? So ngayon, pwede na natin itong ipasok dito sa formulang to. So magiging x2 is equal to b2 square minus p1 na to square over 2a. So, so ito yung magiging formula natin. Ipapasok lang natin to, no? So, mangyayari, yung B1 natin, no? Meron tayong formula na B1 square equals to BO1 square plus 2AX, no? So, pwede natin itong ipasok dito sa formulang to. So, ang mangyayari, magiging x2 is equal to B minus the BO1, 2 plus 2A x 1 na yun. 1 din to. Over 2AX 2A. Yan. So, usog natin. Ayan. Okay. So, dito pwede natin ipasok yung mga given natin. Okay. So, magiging, ano yung B2 natin? Is 12 positive meters per second square. No? Dapat pala to merong ganyan. Minus, start tayo ng 0, no? Plus 2, 2.6. Tapos 1.2. Hindi, 120 meters. Yan. Over 2, no, 2AX 2. So, negative 1.5 meters per second square. Meter per second square din yan. Yan. So, gamitan na natin ng calculator. Calculator. Ito magiging 12 minus 0 plus 2.6. 2.6 pala to, no? Multiply by 120. Over 2 plus negative 1.5. Oops. Parang may mali. Check na natin. Positive 12. Start niya ng 0 plus 2.6. Oh, may nakalimutan tayong 2 dito. Itong 2 na to. May mali pa rin. Check natin. 2 multiply by 120. Bakit 204 ang lumalabas? Dapat ang lalabas is 160. Ulitin natin. 12 minus the quantity 0, no, plus 2 multiply by 2.6 multiply by 120. Tama naman. Tapos 2 multiply by negative 1.5. 204 talaga lumalabas sa akin. So, 204. Labas dito is 204 meters. That's our answer. So, ayan. Okay, so balik tayo sa slide. So, pasok na tayo dito sa tinatawag na free-falling bodies. So, ito yung mga pahulog, no? Tapos di naman sasaluhin. So, okay. Everyone has observed the effect of gravity. So, ang isa sa isa sa mga taong talagang pinagpokusan yung gravity, no? Si Sir Isaac Newton. Nung mahulugan siya ng mansana sa kanyang ulo. So, in the absence of the air resistance, it is found that the bodies are at the same location of the Earth fall vertically with the same acceleration. Furthermore, if the distance of the fall is small compared to the radius of the Earth, the acceleration remains initially constant through the descent. This idealizes the motion in which air resistance is neglected and the acceleration is nearly constant. It is known as a free fall. Okay? Since the acceleration is constant in free fall, the equation of the kinematics can be used. So, dahil constant yung acceleration dito, pwede nating pwede nating gamitin yung equation ng kinematics. Okay? Sabi kasi nila, nakita nila ito sa experiment, yung experiment to ni Galileo Galilei dati, no? Na meron kang isang kilong bato and isang kilong feathers, no? So tiningnan niya pag nilaglag niya to sa Tower of Pisa, sino yung unang babagsak? Okay? So nung tiningnan niya, nung hinulog niya, unang bumagsak yung bato kaysa dun sa feather. Okay? Pero tinitingnan ko kung paano niya nakakuha ng 1 kilong feather. Siguro feather ng ostrich yung kaya nag 1 kilo. So, doon makikita na mas naunang bumagsak yung bato kaysa sa feather. Dahil meron tinatawag na resistance sa air. Pero nung ginawa ulit tong experiment na to na nasa loob ng vacuum, nakakaginalas na parehas bumagsak ng sabay yung bato and yung feather sa lupa. So, yun yung tinatawag na acceleration due to gravity. Okay? So, yun. So, pasok tayo dito sa example number 7. So, tatandaan lang natin, no? Ang tatandaan lang natin dito sa free fall na to, yung acceleration due to gravity. Okay? Yung G. Yung G na to is equal to 9.80 meters per second square. Okay? So, minsan nagiging 9.81 meters per second square yan. Okay? So, pag nakalimutan nyo yan, madali lang yan. No? Meron tayo sa calculator natin. Kunin ko lang ulit yung back side ng calculator ko. No? So, makikita nyo yan sa backside ulit ng calculator nyo. Yung letter G. Okay? So, saan ba yung letter G na yon? Sa constant, anong number yun? Baka 36. So, Chef 7, 36 ata. Ay, hindi. Sa calculator, alam ko nandito yan eh. Hindi rin. Ay, ayun. Chef 7, 35. So, ayan. 9.80. 80665. So, pag nakalimutan nyo yung constant ng G, punta lang kayo sa calculator nyo. Chef 7, tapos, number 35. Yun. Acceleration due to gravity. Okay? So, punta tayo dito sa problem number 7. Sabi niya dito, a stone is dropped from the top of the tall building. So, makikita natin dito sa figure na to, no? So, after 3 seconds of free fall, what is the displacement y of the stone? So, ano daw yung displacement na y? So, sabi nila, meron daw inilaglag na bato sa taas ng building. So, ang tinatanong, nung mag 3 second, gaano na kalayo yung um, itinakbo ng bato natin? So, dito, pwede natin gamitin yung formula na yung x palitan ko na ng y, base doon sa figure. Magiging y is equal to initial velocity multiply by time plus 1/2 a t square. Okay? So, yung acceleration natin dito is pwede natin gawing g. Ayan, yung a nilagyan ng buntot naging g. So, yun 9.80. Okay? So, gamitin natin dito is 9.80. Huwag muna tayong gagamit ng 9.81. So, kailan ba tayo gagamit ng 1.81? Kapag merong multiple choice tapos hindi lumalabas yung answer nyo, try nyo gamitin yung 9.81 yung base of 9.80. Okay? So, dito, ang initial velocity kasi natin dito, no, is 0. So, automatic magsi-0 na tong dalawang to. Ang matitira is 1/2 gt. Diba? So, magiging 1/2 gt, yung g natin is 9.81 meters per second square. Yung time natin, ibinigay niya after ng seconds, 3 seconds square. So, ganun lang. Kasimple, no? So, nawala ata yung calculator ko. Ayan. So, yung 1/2 multiply by 9.81 tapos 3 seconds square. So, ang lalabas dito is 44.145. No? Naging 44.145. Okay, meters. And dahil pababa yan, no? Dahil pababa, yung acceleration natin dito dapat negative kasi pababa. So, negative din to. So, ibig sabihin ng negative is yung pababa. Okay. So, answer natin doon sa problem. Okay. So, same yung concept, same yung building. So ang tinatanong niya naman dito, ano daw yung velocity after ng 3 seconds. Okay, so madali lang yan. Meron tayong formula ng velocity na v is equal to initial velocity plus at. And sa ano natin, sa scenario natin magiging gt. And dahil wala siyang initial kasi naka-rest siya, automatic magiging 0. So b is equal to 9.80 meter per second square. Multiply mo lang ng time na 3 second, automatic makakancel yung isang ano dito. So magiging ang velocity natin is ilan ba? 9.80 multiply by 3. So magiging, dahil negative nga to, di ba? Nakakalimutan palagi natin negative yan. So magiging negative 29.4 meters per second. And this is our final answer. Para dun sa problem na yun. So number 9, example number 9 naman tayo. A football game customarily begins with a coin toss to determine who kicks off. The referee tosses the coin up an initial speed of 5 meters per second. In the absence of the air resistance, how high does the coin go above its point of release? So, gaano daw kataas yung maaabot nung coin na pinag-toss? Okay? So, paano natin to i-approach? So, analyze muna natin, no? Analyze natin. Meron daw coin na tinos pataas. Tapos bumaba ulit. Ito yung hinahanap. Sabihin natin y. No? So, pwede kong gamitin yung formula dito na BO. No? Ay, hindi yung B2. B squared over BO square plus 2AY. Para mahanap natin yung Y. So, para ma-isolate natin to, or simplify na lang natin, no, yung Y. Paano? Kaya analyze natin ulit. So, pwede ko tong gawing B squared minus BO plus 2AY. Tapos, teka. May mali. Is equal to AY. Tapos, i-divide ko to. Magiging B squared minus BO squared over 2A. Magiging Y yan. No? Pwede ko nang gamitin tong formula na to. And dahil yung initial, hindi, yung final niya, 0. Bakit 0? velocity. Siyempre, pag tinos mo yan pataas, tinos mo siyan pataas, yung velocity niya sa point na to is zero. No? So, magiging zero yan. So, ang mangyayari is negative b initial square over 2a na magiging y natin. So, di ko na lang magiging y equals to negative 5 meters per second square over 2a. Yung 2, yung acceleration na binigay niya is acceleration due to gravity na negative 9.80 meters per second square. So, using your calculator, our calculator, lalabas yung answer dito. Nagiging negative 5 square over 2, negative 9.8. So, lalabas dito is 1.2 meters. Layo ah. Layo nung pagka-Toscoy na. 1.2 meters. Lakas. So, yun yung final answer natin. Okay. Oops. Saan na pumunta yun? Okay. Shift F5. So, punta na tayo dito sa graphical, no? Last topic sa para dito. Punta tayo dito sa graphical. So, dito kasi sa graphical, so, graphical technique are useful in understanding concept of velocity and acceleration. Suppose, meron tayong nagbe-bisikleta na nagra-ride with a constant velocity na sabihin natin na 40 meters per second. So, kunwari meron tayong nagbabike na merong velocity na 4 meters per second. Tapos, dun daw sa position X, sige, ganito. Gawa ako ng graph. Yan. So, dun daw sa position X, the bicycle can be plotted along the vertical vertical axis of the graph. So, pwede sabihin natin ito na position. So, dito yung position. X. No? Tapos yung time naman natin, pwede natin ilagay dito. Ayan. Since the position of bike necessary is 4 meter every second, no? The graph X versus T is magiging straight line. So dahil constant naman na 4 meters per second yung velocity niya, no? So mangyayari ang graph natin is ganito. Ganito yung magiging itsura ng ating graph. Yan. Straight line lang siya. Okay? So parang ganito na yung magiging graph niya. Okay? So every position daw ng line is makikita natin yung position niya and depende sa time. Okay? So kunwari is 1, 2, 3, 4, 5 1, 2, 3, 4, 5. So, in 1 second, nasa 1 meter siya. Nasa 4 kasi 4 meter per second. 4, tapos 8, magiging 8 to. Ito naman is magiging 12, tapos 16, and so on. So, dito is 1, 2, 3, 4, 5. So, kunwari, nasa time niya is 1 second, nasa 4 meters siya. Time niya is 2 second, nasa 8 meters siya. Ganon. So, in constructing the graph, we used the fact that velocity was 4 meters per second na positive. So, suppose however, we're given the graph, but did not have a prior knowledge for the velocity. The velocity could be determined by considering what happened to the bike between the times of 1 and 3, for instance. So the change in time equals to 2 seconds. During the time interval, the position of the bike changes from positive 4 to positive 12. So the change in position is magiging change of x equals to 8 meters. So yung ratio nung change on so yung magiging ratio nung change of x over the change of time is yung tinatawag nating slope. So ano yung slope na yun? So yung slope na yun is parang ganito. Okay? Kunwari, this is the change of x, this is the change of t. So yan yung slope natin. So kunwari, meron tayong hanggang 4, no? Kunwari, nasa 2. Dito sa 2 na to, syempre 8 din yan. So yung x natin is 8, tapos yung t natin is 2, no? So pwede nating sabihin na yung slope natin is magiging 8 over 2 or 4 meters per second. Okay. So ganito yan. Kunwari, hindi ibinigay yung velocity. Binigay niya lang yung graph. So sa graph, ma-analyze mo kung ilan ba yung velocity niya. So ganun lang yan. Okay? So punta tayo example para mas maintindihan natin. So, a bicycle trip, isang nagbe-bisikleta maintain a constant velocity and on the outgoing leg of a trip. So zero velocity while stop. Okay? So kapag zero velocity daw naka-stop and the other constant velocity on the way back. So makikita naman natin dito sa figure the corresponding position time graph. Using the time and position interval indicated in the drawing, obtain the velocity for each segment of the trip. Okay, so paano natin makukuha? So meron siyang tatlong trip, no? Kukunin lang natin dito yung velocity niya. So napakadali lang nung hanapin ng velocity na yun. So sabi ko nga kanina, i-analyze lang natin. No? Sabi ko nga, i-analyze lang natin. Dito na ako maglalagay. So, sa first trip niya, simula siya sa 0 papuntang 2. So, kukunin lang natin yung slope. So, kunwari sa 1, at 1, 1 yan ha. Ang slope nito is magiging 400. Tama? Tama ba? Ang slope nito is magiging 400 over 200 seconds. Okay? So, kunwari dito, Para mas maintindihan natin, no? So, ito. So, kunin natin sa part na to. Sa part na to. Okay? So, magiging 800 minus 400 para makuha natin to, tama. Okay? Para makuha natin to. So, magiging 800 minus 400. Over, sa time naman, magiging 400 minus 200. So, mental math, ang lalabas dito is 400 over 200 or 2 meters per second. Positive. Si pakyat. At 2 naman, no? 0 yung position x. Tapos time. Kunwari dito, 600 yan. Yan. Ayan. Okay? So dito magiging nag-start siya sa 600, 1,200 yung ano niya. Tapos nag-stop siya sa 1,000 seconds. No, 1,200 pa rin. So 0 yan. Over the time na 1,000 minus 600. Tama. 1,000 minus 600. Kaso, 0 na yung nasa taas mo. So automatically magiging 0 to. So ibig sabihin yung velocity niya sa 2, 0. Wala siyang, tama, 0 velocity. Tapos, bumalik siya ngayon sa position niya. So, mangyayari dito, ito kunwari dito sa segment na to. So, dito naman is 800 minus 400 or 400 minus 800. Kasi 400, no? Sa 400 minus 800 over yung time natin is 1,800 minus 1,400. So, ang lalabas dito is negative 1 meters per second. So, ganun lang siya. Ganun lang yung pagpa-analyze ng graphical analysis. Okay? So, that's the end of the presentation. So, tapos na tayo doon sa tapos na tayo dito sa kinematics na one dimension. So, next naman, i-discuss ko yung two dimensional. So, katulad din na natin kapag meron kayong question, ilista nyo lang lahat para sa susunod, i-discuss natin. Okay? So, hanggang dito na muna ako and thank you so much. Goodbye.